Very good afternoon, sir.
Yeah, very good afternoon. Very good
We
afternoon.
welcome you to the second day of this workshop. So, very good afternoon to all of you, all the participants of the workshop. We are heading forward with the third session on the second day of the workshop on DATASCULPT. At the outset, I invite Professor Dr. Amlan Chakrabarty, Director A.K. Chowdhury School of Information Technology, University of Calcutta. Welcomes you, sir. You have a marvelous profile. I'll be honored to read your profile, sir.
No need to read much. I think
Yeah.
most of the people knows me. Okay, so let's not waste much time. I can just start from here.
Your graduation was done in 2019. You completed MTech from University of Kolkata in 2001. You did your doctoral degree from the same university in collaboration with ISI Kolkata in 2010. You were a post-doctoral fellow at School of Engineering, Princeton University, USA. From the period 2011 to 2012. You have almost 20 years of experience in engineering education and research. You have received many of the achievements and accolades. Noteworthy of them to mark few are DST Boyscast Fellowship Award in Engineering Science in 2012, Indian National Science Academy Fellowship, like Visiting Faculty Fellowship in 2014. You have also received JSPS Invitation Research Award in 2016. You were also awarded with Erasmus Mundus Leadership Award in 2017. You have, to your credit, Hamid Visiting Professorship from University of Cambridge, UK in 2018. Shiksha Ratna Award by Department of Higher Education, Government of West Bengal in 2018. IBM Quantum Research Access Award in 2021. That's great. You have received multiple project grants in the areas of embedded system design, VLSI design, quantum computing, computer vision, cybersecurity, IoT, from funding agencies like DST, MITI, DRDO, DA, and Ministry of Social Empowerment, also UGC, TCS, and Intel India. You have also served in various capabilities in various higher education organizations, both of national and international repute. You have, to your credit, various publications, around 160 plus research publications in refereed journals and conferences, 4 patents, 1 copyright, and have 16 PhD students till date. You are an associate editor of the Elsevier Journal of Computers and Electrical Engineering, series editor of Springer Transactions on Computer Systems and Networks, guest editor of Springer Journal of Applied Sciences. You are a senior member of IEEE ACM, distinguished visitor of IEEE Computer Society, distinguished speaker of ACM till 2020. Sorry, there was a glitch. And your main areas of research are machine learning, computer vision, reconfigurable computing, cyber physical systems, VLSI CAD, and quantum computing. So we are honored to have you here, sir. So the mic and stage is all yours. I invite you for the session. Thank you.
Yeah, thank you, Professor Aparna. Okay, for this brief introduction, and thanks to organizing team. I don't know much about the organizing team, but some of the people are very close to me. They connected me, and that means and now I am so much busy. But I just finished my tour from Malaysia and just landed on Monday evening here, and then again tried to finish my all all the works which are pending at my university and other of my work domains, right? So I'm very busy. So I'm sorry that I couldn't join in time. I was finishing my pending meetings, okay? But still, that means I am there, and I will try to do the justice of the time and on the topic of interest. So I will just start straight away from here. Um, okay, my lecture will be on something which is very interesting now, at least at the present scenario of okay, large language models. So I will I will speak upon yeah. So I hope that the screen is visible to all of you, right? Is my screen is visible to all of you?
Yes, sir. The
Okay,
screen
great.
is visible.
Okay, great. So this is the topic that okay. No, sorry, this is not. I will just try to change it. This was not your topic. Sorry. Let me go to the folder. I think this was not. Let me just think your topic was different. Yeah. So I think this one was the topic. Sorry, it was same setup. So okay. So what I will present today is the topic which is called as demystifying Gen AI. Okay, and what are you? Demystifying Gen AI. Okay, so we know that Gen AI is is something which is very happening, generative AI, and we'll try to understand what are the basic premises of generative AI, right? In as simple as possible. Okay, so let's move on. So we know that the difference between traditional AI, which is more known as discriminative AI, right, is that discriminative AI is that given a particular sample or given a test input, okay, the model which has enough knowledge about the domain can tell that what this input is, in a sense that it can tell if it's a classification model, it can tell that what is the class of this input, okay, in the sense that I give an image of a tumor, right, or a brain lesion, okay, my my model, right, my AI generated model can tell that whether this lesion is in class benign or in class malignant, okay, which means that it can identify objects, okay, in the domain based on a learning model which has been developed or captured, okay, by the model through a process called training. The other thing also, it can do something like clustering, which doesn't go through that supervisory learning or training. It can tell that, hey, these two objects are very close to each other, okay, so these two objects are very close to each other, or these two objects are not very close to each other. So okay, so you can do like that as clustering, or it can actually tell that, okay, if I generate a sort of, right, if I combine a certain set of values, right, and I define an outcome which is to be forecasted, what will be the outcome if we combine these values, okay, suppose, okay, what will be the rainfall of this what will be the rainfall of this particular place, provided we know the temperature, the humidity condition, and the wind flow in the particular region, and the cloud cover. All these four parameters, if I give their quantified value, can I predict that what will be the amount of rainfall happening in the next 5 minutes or next 20 minutes? Okay, so these are all AI models which are called discriminative AI models, which goes to prediction, classification, okay, which is basically identifying a pattern, right, or predicting an outcome. But generative AI, which is another very strong outcome of this AI models, is something that what it does, it tries to generate samples from a distribution, and that's so important. Though the entire problem of machine learning, those who can perceive that, is basically understanding samples and the distribution in which the samples belong. Okay, so when you take classification, a classification problem, what it does, it goes to the distribution and it tries to identify each sample as class 1, class 2, class 3, something like that. If it's a clustering problem, it tries to find that, okay, these two samples are pretty close and these two samples are pretty not close. Okay, and if it's going to prediction, then it can tell that this sample can lead to this value. Okay, so that means it gives a sort of measuring, quantifying the samples outcome in case of prediction. So understanding samples and the samples in a given domain means that there is a distribution of the samples, and you can work on the that means in the distribution and on the samples by traditional machine learning models. But what generative AI does, it can create distributions. It can create samples within the distribution, but generative AI can also create new distributions. Okay, with the knowledge of large distributions. Okay, that means if you learn multiple distributions, if you make the Gen AI model to learn multiple distributions, it can generate its own distribution. And that is a tremendous thing, because this is the scope where you can generate samples, right? And this was not a very and this was not in our thought process initially that, okay, generating samples can be so important, but it came to our thought process once this large language models evolved. So what the large language model generated, they generated different types of replies, okay, within a given domain. And these replies are nothing but actually abstract some sort of feature components, right? And generates a sort of equivalent to a sample in that particular domain, right? And these replies are so important for us now, right? We can get a lot of informations of the domain, okay, by understanding by using the generative AI, which creates new samples from the domain and makes us understand. Okay, so let's go ahead. And this Gen AI is not only limited to text; it can be images, music, video, audios, and so many more. Okay, so this is a very good example that what Gen AI can do. Okay, so what we see here is that, okay, there are images, right? And there are expressions. So what can be done is that a particular person is making some expression, and those expressions are overlapped or being transferred to some of the face images, okay, which were actually not there. So if you see the top row, what it is doing, there is a girl, right? If I try to again play this, there is a girl, okay. She is go back. Yeah. So the girl in the top left is actually giving some expression, and those expressions are copied over two images. Okay, one is Mona Lisa and one is Brad Pitt. Okay, so they are carrying the same. And similarly in the next row, we will see that one of the person is moving his face, and it is it is getting copied, okay, to other personalities. So how this is done? This is done through the process of generating the samples in a particular domain, okay, based on some sort of modification of certain latent space feature. Okay, so what is done? The feature of the unknown of the character male and female, top left and just the bottom, the extreme left, their features are being extracted. Their motion pitch feature extracted, and then in the distribution of the other personalities, okay, their distribution is augmented by the features which are being captured by the new inputs. Okay, and similarly you can do this by text generating image, which is shown in the next example on the right. Okay, you give a prompt. A prompt is a sort of, what I can say, prompt is a sort of information to your Gen AI model. It can understand the tokens in the information, and based on the tokens, it can create the sample. And the creation of sample can be image, which means that it takes the text tokens, and it creates the distributions in the color patterns, in the intensity patterns. So these are something where the multimodal activities in the perspective of Gen AI comes up very well. The most common is shown in the left bottom, where we give a text prompt and a text reply comes. The way the text prompt is captured, first of all, is that in terms of the understanding of the text prompt. First thing, this is an LLM model, large language model. So what a large language model does, a large language model can understand a natural language, a text written in natural language. So you write a text in English, but you give some sort of hint, and those hints are very important in the prompt. Like I've given the hint that, hey, the style should be William Shakespeare. It will be on some generative AI, 50 words, formal tone. So these are all the hints that are given. Now the generation process of this particular natural language input is encoded and understood. And then based on that, you make a seed for generation, right? And the generation comes again from the learning of that means how the words will be organized. And the words will be organized with some sort of basic English correctness. On the top of that, there will be the prompt, the prompt based, the token based actions will also be taken, like it should be style William Shakespeare, it should be of 15 words and all these things. Okay. So as I said, that the two classes of AIs are descriptive AI and Gen AI. Descriptive AI is the more common AI, which we work with prediction, classification, predict decisions, generate decision boundaries, try to find similarity between the objects and patterns, okay, like that, okay? Whereas Gen AI is something which generates new data. Now, to generate new data, what you have to understand that what is the distribution in which I have to create the sample. because any data is a sample in a given distribution. So we have to understand the distribution, and you have to generate a sample within the distribution. And to do that, there are 2-3 techniques. Obviously, the generative adversarial network is one technique. Variational autoencoders is the other technique. And the other technique are the attention-based techniques, which are also called autoregressive models. So now if we look into the why we are discussing so much about this Gen AI and AI, because obviously the AI market is very much increasing. It's going very, very much high. Okay. It is going very, very high. Okay. Now there are a lot of in terms of Gen AI, there are a lot of things have emerged. In case of Gen AI, a lot of things have emerged, right? So there are a lot of tools have emerged. It is not that all the tools and all the platforms are going very well, but obviously some of them like Bard, okay, which has been converted to Gemini of Google, okay, GPT-4, right? These are really going very strong, okay. But the work started from 2019, right? Basically from Google, from OpenAI, from the Meta, they all started, and also there were small groups who also started their own. And then now what has been coming up is that Gen AI for domain specific Gen AI. It's, okay, now it's not only that in the entire English domain, English language domain. It may be a Gen AI which is working for especially for the media, maybe Gen AI for sports. Okay, these are the things that also which are coming up, right? And as I said that Gen AI can do multiple things. Okay, only you have to understand the limitation of Gen AI is that it doesn't compute. It is not a computer processing. What we do generative AI is basically trying to, that after learning the domain and the distribution of the domain, generative AI can generate samples in the domain, but it doesn't does any sort of computation. So if you tell that, hey, Gen AI is just like a genie, will do all tasks for me? No, it's not like that. If you tell, okay, Gen AI will actually execute a query and give me a result, it's not like that. But Gen AI can generate the text for the query. Why? Because it has an encoder decoder procedure by which it can understand your English requirement, and based on its knowledge model, it can know that how the English requirement can be transformed to an SQL language specification. And a SQL language specification is a database query. So it can generate the database query, but it cannot execute the database query. Okay, this you have to understand, that what Gen AI can do and what Gen AI cannot do. So Gen AI, you shouldn't take that Gen AI is a sort of your application. No, Gen AI is a sort of interface to your application. Okay, where your input can be curated to a particular form and put into the application, and the output from the application can be curated to a particular form and can be thrown back to you. Because all these things can be well done in Gen AI. Okay. Now, as I said, that there are 3 types of architectures. One is called the GAN, one is called the variation autoencoders, transformer architectures. This all architectures are very deep in terms of the conceptual and the functional way the networks are being built up. Due to the limitation of time, I will not get into the details of the network, but I will try to give you an idea in a very conceptual form for all these things. Okay. So when we say a GAN means generative adversarial network. Okay. So GAN means a generative adversarial network. So what does it mean? So generative adversarial network means that it is a network consisting of two components. Okay, one component is a generator and one component is a discriminator. So what a generator does, generator initially starts with a random generation of samples. So as I said, that generative AI means that you have to generate the samples within the distribution. But when somebody starts randomly, right, that means he or she doesn't have any knowledge of the distribution, right? The sample will be random. Now, how to ultimately make generator understand the distribution, that is the job of a discriminator. Okay, so what discriminator does, the discriminator checks the sample generated by the generator and say yes or no. Yes means yes, the sample is correctly generated, which means that the sample can be a part of the distribution in the domain what I have learned, because I will come it is the discriminator also learns. It's not that the only generator learns. Discriminator also learns the domain, and through its learning, it can distinguish the sample generated by the generator is true or false, means is whether the domain or not. Now suppose it's very obvious that the first instances, as a discriminator doesn't have any knowledge about the domain, discriminator what sample produces, okay, the generator will tell it's wrong, so it will be a no case. Now from this no, it will try to, okay, from this no it will try to make the next step, right, and try to vary the parameters a little bit in a different way and try to generate the next sample. So in this way, the discriminator goes on generating the samples. Sorry, the generator goes on generating the samples, and discriminator goes on checking the samples. It is something like that, that when you prepare a food and there is a tester who tests and tell that no, still something more is required. No, still something more is required. And ultimately, you know what are the basic premises of this domain. You know the basic cooking means some masalas. So you know that you have to plus or minus some masalas in the particular food. And ultimately, at one point of time, the tester can tell that, hey, your food is very good. So that's the point where the discriminator accepts the generator, and from that, the training of the generator is done, and then discriminator can be taken away, and generator can go on running, and it guarantees that whatever generator generates now is a sample within the domain. But you can also ask me, what's the role of discriminator? So discriminator is also something, it also learns so that it understands the domain very strongly, so that a minute deviation from the domain, if a generator generates, right, it can inform the generator that you are out of the domain. So the learning of discriminator is also very important, because that will tell that whether the generation of a generator is within a skewed part of the domain, or it is really in the entire domain. Because if the discriminator is not well trained, okay, then it will only, okay, well trained means a weak learner. Okay, not well trained. If a discriminator is not well trained, means it's the weak learner. A weak learner means it can only understand a skewed part of the domain, not the entire part of the domain. So the generator, okay, cannot. So if a generator passes the discriminator also, it doesn't guarantee that a discriminator will be valid in the entire domain. So that is the entire crux of what is a discriminator, okay, and generator. Okay. So the other part is the variational autoencoder. So the concept of autoencoding is that there is a concept of latent space representation. So what is a latent feature space? A latent feature space is something which actually defines the minimum representation of the feature space. Okay, which means that this amount of feature space is sufficient enough to understand or to write or to represent the sample in the domain. So how does it helps? The most primary domain of autoencoder, if we just leave the variational part, the primary domain of autoencoder was the dimensional reduction, which means that whatever excess layers are in the feature space, if those can be shaded off in a sequence, can we still have a representation in the feature space which is sufficient enough to regenerate the sample? So it is said as a compressed representation. Now the encoded representation, which is called a compressed representation, requires a decoder which will accept this encoded representation and will decode it maximally so that the exact sample can be regenerated. So a sample in the feature space is being encoded and it reduces the feature space by a certain degree, and that feature space where you can still represent is called lattice feature space, and that is the sufficient number of features, sufficient amount of feature space from where we can, again using a decoder, can regenerate the sample in the original distribution. Now this is fine in the normal autoencoder. Now what variational autoencoder does, a sort of perturbation in the lattice feature space, and these perturbations generates different variations in the distribution, and these perturbations represents that these variations can generate new samples which can be the part of the same distribution, and that's what is the variation autoencoder does. And with the variation autoencoder also you can generate new data in the given distribution. So everything is, I mean, if it was a simple autoencoder, it was the same sample which was represented in a compressed form, highly reduced dimension form, and it goes out again using a decoder to the exactly the same sample. And the difference in the variation autoencoder is that means you understand some set of samples, understand the latent space, and then do some sort of statistical parametric variations, and can lead to some new samples of the domain. Okay. The other important part is called the transformer architecture. Okay. So the transformer architecture is something which actually uses the same encoder decoder. Okay, but the only difference here is that it actually works with some attention. Okay, the attention means that you try to give some high priority to some of the features in your feature space. Okay, and that attention makes your clarity in the decoding better, right? Though it started from the text analytics, where you can give certain phrases or certain qualitative tokens which defines the entire story better, and you can capture more information about the content if you can give a proper attention. Now obviously the question comes, okay, so I will come to the attention again of a little bit. So this is a very simple way how the encoder decoder works. Okay. So this is an example how we can just convert an English text to a German text. Okay. So how we do it, it's a sort of very simple way that how you do the in the case of this Java, right? You know, the Java is a language which which can be compiled in any particular platform and can execute in any other platform. Because why? Because Java compiler doesn't generate the assembly. Java compiler generates an intermediate code which is called a bytecode. And this bytecode can go to any other machine which has a Java virtual environment or Java runtime engine, and can be decoded to the native assembly of the particular platform. So here is also a similar thing. Okay, so the encoder captures the input string and passes to the decoder. Okay, decoder has also a particular so encoder also requires a knowledge to encode this particular strings to a particular form, and decoder requires a knowledge so that to transfer or to modify or to map this representation to a specific type of language content, okay, at the output. Okay, so now if we try to come into the attention, so this on the top of the encoder decoder works fine, but it has been understood that to make the encoder decoder work more in a qualitative form, attention is very important. So what is the attention? Attention is estimated by a metric. Okay, so what it does, it actually works with three parameters: Q, K, V. Okay, so your Q is the what I can say is the query. Okay, so what I try to do, it tries to find the representation to a particular keyword K. Okay, what its attention value in a given query, okay, compared to all the strings present in the query, or compared to all the inputs given in the query. Okay, so if we look into this particular form, so what we will do is that we will try to given a query, given a key, right, and what it is value, attention value, it is a probability of the spreading of the k, which is root over dk. It's a diameter of the k within that particular string. It's a parameter, and there is some sort of constant factor capital T, and small v is the value. So you try to generate the attention of a particular different positions of a single sequence. Okay, so it tries to generate attention of every token given in a sequence. Now, if we go in a multi-head attention, which is also found better than self-attention, this is a normal attention, self-attention. Multi-head attention means that it is actually, we try to give the different types of values to, that means we try to combine this, generate this particular score in different weighted factors, and the weights can actually vary. Okay, so what it does is that it tries to get a cumulative score from different types of weights of this particular keywords, and estimates the sort of average, okay, the attention value of the keywords, and based on that you generate the attention of the keywords. Okay, so the attention of the keywords actually helps you to decode the particular particular information in a better way. Okay, and there are several ways we can do this. There are very good publications you can do, right? How you can understand the sequence, and you can use the attention to understand it well, right? So that its features are preserved, right? Multi-head attention sometimes works better than, say, self-head attention. And these are all the tasks of the problem. Okay. Now when we try to develop the knowledge, okay, many of the times what happens is the case that, suppose, the large language models, like you can tell that, okay, large language models, how they can curate a particular query, because large language models are training on finance, are training on okay, that means if you take it's going on different data, it is getting trained. So what is done in many of the cases, you are right, you can use a sort of thing called transfer learning. You can use a thing called human in loop, right, which can actually curate a very large model to which is trained with a very large amount of data to a very specific use case. Okay, so human in loop is one of the case which you tell that is called HIL, which we do that. Okay, that means the large language models at the first instance, okay, it generates a lot of garbage, right? And human in loop, an expert can tell that, hey, this is a garbage and this is a correct. So once you tell this is a garbage, the LLM model gets trained that, okay, these particular outcomes will be very, very low prioritized, or these outcomes, okay, generation of these outcomes will be stopped out, right? And these outcomes, okay, will be taken. So it adjusts its generation model so that some of the outcomes are stopped and some of the outcomes are preferred, right? So in this way, it tries to work on that. Okay, and what it and okay, and now okay, and if you look into these are used for fine tuning these models. Okay. And now we look into some of the prompt engineering, which are very interesting. Okay, so prompt engineering itself gives you a learning scope. You will see that means that with the prompts itself, okay, gives a sort of scope to the to the model to get to know that how it works. Now, normally it can be a very flat type of prompt, which is called zero-shot prompt. Okay, where you just tell whatever is there, you just give me. Okay, but there are a few short form prompts, like you can give some sort of parameters. Okay, give some sort of more data to help it. Suppose I tell that, hey, give this content in terms of Shakespearean mode, okay, right, or right, or give it in terms of a marketing or academic type of style. So this helps the prompt to actually take those clues, right, and actually update its output. It's called few shot. Update its output as to match the clues what have been given in the prompt. Another one is the chain of thoughts, where you can give a sort of multiple ways it can create. So it can give you can tell that, hey, you do this, and then you generate this to me. So this gives the backend generator, because everything you have to understand, the generator is now generating. Okay, the generator can understand that, okay, this is the process I have to follow for generation. And so these are different types of ways how you can help the generator. It can be a flat, it can be some hints, or it can be a sequence of operations you can tell, so the generator can work well. Okay. And obviously, when we go to the GenAI tools, we have different types of GenAI tools: text, image, video, music, art, right? So, but there are options. There are options which actually holds us. There are options which holds us to take this GenAI thing, okay, to not very in a very negative way also, because we know that a lot of, if we can generate videos, and there are techniques I didn't discuss like cycle GAN, which was okay, shown a little bit in the example, right? We can create not many things new which are not actually there, and this is something called fraud. If you can create something which is an image or a video, because normally image and video means we are trying to capture it from the real scene. But if you can generate image and video through your generative AI, and purposefully you do it for tarnishing one person's image, organization's image, or country's image, or entire world's image, it is really, really very bad. So there are things called deep fakes which are exploiting this, okay, scenario of generative AI in the video, music, right, all the things. So you don't know in many of the cases that whether in a very naive way whether it's a generative AI or it's the original thing. So previously we know the video cannot be generated. Music cannot be generated by instruments. It can only be captured and stored. But now video can be generated, music can be generated, image can be generated, text can be generated, poems can be generated, your art can be generated. So now there is obviously a challenge that to understand that who are the original creators from intellectual thought point of view, or what are being created by your tool like generative AI. Okay, this is a little bit okay, what I can say, a crossroad we are here at the present point of time. Okay, not getting details on the chat GPT, you know, these are the very useful and well-known platforms. Okay, and prompt engineering, as I said, the prompt engineering goes to, it is not that the LLM has been just trained by so many corpus of data and it worked out like that. There are a lot of human experts in the loop, okay, were there, who had actually say that, it is wrong, it is good, or said that, okay, this is better, this is not better, this is good, this is worst, by which, okay, the feedback from here help this type of generative model to work better, okay, with the help of a domain expert. So many of the medical, educational services, medical services, domain specific agricultural services, financial services in the future years will be coming up based on this generative AI, but with a strong cover that there are experts who are involved here, and we have curated the generative AI in a proper way so that it fits the requirement. So generative AI without any sort of curation, without any sort of human in loop, that can be very, very wild thing, okay, which we don't want. And these are some of the things that we know that there are things which are coming up where we can have a text and image working together. A lot of research groups are now coming up. So you have an image and you have a text. What do? That means if you have to change the image, you have to edit the image. So you understand the text tokens, right? Take it to the image editing tool. Image editing tool understands the text token, okay, to the decoder, and then it actually changes some of the pixel information and recreates a new image. And this is what is being shown in this particular example, which is called DALL-E, which is also an OpenAI product. Okay, I'm not getting into details of this. So next step multimodal. So it's not that it's only the text to text conversion will be there. So you give image, you give text, and you create a video. But suppose what a wonderful life would have been if I say that, hey, generate a soccer video where Lionel Messi is scoring a goal from a free kick, right? So I give a text, I give some of the maybe some of the images of Lionel Messi, right, or videos of Lionel Messi, right, and it can create a new sequence of images. That can be a little bit creativity, and it can do that. Okay, so these things are helped in media. These things are heavily helped in medical diagnosis, right? This was not being thought in a way, but now it is being heavily thought. So So doctors can create visual scenes of different type of surgical interventions prior to going to surgery. If my generative AI can create the exact scenarios of the patient internal structures, what the doctor has to go for operation. And there are something which you cannot see and cannot capture, but generative AI can still generate those using your inputs. And if they are generated, they will be a wonderful source of knowledge for you. But having said so, you shouldn't generate things in generative AI which causes harm, because generative AI can generate. Now it is your control on the tool, your engineering on the tool, so that to stop which is not under compliance, which is not ethical. You only generate which is within the compliance and which is ethical. So compliance will be a major thing which will be driving the AI, next generation AI and generative AI in the very true sense. Compliance will be coming up, and those will lead us to safe AI, because now the AI is something that which is not safe, because it is some people can exploit it in different way. Okay. So as I said, challenges: data security and privacy. You are trading with a huge amount of data, right? That it is your data. How you know that it is your organization data? How you know that this is completely private and secured? Okay. Algorithmic bias. When you train your model, right, you have a skewness in the distribution. Say class 0 is, suppose we are doing an employment or some employment a prediction tool or an employment mapping tool, right? So it might happen a particular group of community were not so well educated 20 years ago, or a particular section of population were not so educated 20 years ago, but now they are doing fantastic. Okay, but if you take the data of 20 years ago and using the training, okay, then hardly this community of people will get a chance in the placement, because their past history says that these people have never got placement. So these are the biases which can happen, and this has happened much in employment industry, and people have been legal challenges have been made, right? As I said, so ethics and legal compliance framework should be there, right? And it should be cost and sustainable. Transparency and interpretability. So it is not that, oh, what AI has done, I don't know. Okay, obviously AI is a black box, has done something, but how it has achieved this, and what are the paths it has taken to achieve this, what are the priorities that have been there in your data set, this should be perfectly known to all who are using your AI. So the challenge in the AI is that when you use an AI tool, you don't know how this AI tool was developed, and you just blankly depend on the AI tool that, hey, this is giving the answer, it's correct. So this is a particular thing, because unless you have an understanding of the interpretability and transparency of this AI tool, whatever this AI tool is generating for you blindly, it's not good. It can lead to the wrong consequences. Okay. And as I say, reliability and safety is one of the issues. Reliability means that, hey, my AI tool can work on this domain of data or this amount of data. If I make a larger data set, or if I move into other domains, whether this is reliable. And safe means whether the outcome what is generated is good for my life, whether it is just it is generating something which is very, very painful to me. Okay, painful for someone, okay, who's operative. So these are something like safety. Okay. So a lot of things are generative AI based applications are coming up, right? A lot of good hopes are there for Gartner, and I hope that this is evolution has started. And obviously, it should be a very careful way of using the Gen AI, not a very rampant use of Gen AI. But if you can use Gen AI very carefully, it increases the productivity. there is a question I face in many of the that discussions that GenAI will kill the jobs. Yes, it is. It is true that GenAI will kill the jobs who are just taking data from corpus and using them in their work. Okay, so the worst class of manpower will be completely taken over by GenAI. But the best class of manpower, GenAI will never get to match, because best class of manpower think and create, okay, which are not there. So when you think and create something which are not existing, that GenAI cannot do. And for that, you always have to be there, right? And to understand, and you have to be in a level higher than GenAI to understand whether how to apply GenAI. What are the prompts I need to give to GenAI? Okay. Sometimes in our, as we are a teacher, sometimes we tell that, okay, students shouldn't use GenAI to generate the assignments. But I prefer a student where the assignment is very deep, as a student can solve the assignment only if he or she can give a good prompt. Now, when you are giving a good prompt, means you have a thorough understanding of the domain. If you don't have an understanding of the domain and your requirement, you cannot give a good prompt. So if I give an assignment to a student which requires a good prompt, and the students can generate that prompt and give me the assignment, then I'm very fine. Because to do that generate that good prompt, you need to understand the domain as well as the problem. Okay? So that's all. Thank you. And I hope I am within time. And if there are any questions, I will be very fine to answer. I'm ending my presentation now. Yeah.
Okay, thank you so much, sir, for sharing advancement of AI. We have some questions from the participation side.
Sure, please. Please go ahead.
Hello? Yes, sir.
Yeah, please go ahead. Please ask
Yes,
me.
sir.
Yeah.
So, first question is, how can AI be integrated into traditional industries such as manufacturing or agriculture?
Excellent. This is very much. Okay. So manufacturing. As I said, I was visiting Malaysia last week. Okay, and I visited their scientific establishment, government of Malaysia IT establishment called MIMOS. So they are doing precision manufacturing. And in precision manufacturing, there are a lot of chances of errors and faults in manufacturing. So how you identify them? How you identify those faults when you are generating products in a particular sequence of operations, and large number of products are generated. So you cannot have a physical inspection of all those. So each of the product goes to a verification bed where there are a lot of sensor-based scannings, optical scannings, microwave-based scannings, all these are there. And the data what the scans generate goes to a machine learning model, and the machine learning model analyzes those scan data, can tell if there is any type of manufacturing error or manufacturing fault has got into the product. This is one use case, okay? Second use case is that whenever you are doing manufacturing, right, we are also working with something called wastewater treatment plant of L&T, Larsen and Toubro Constructions. They have a plant in Varanasi, and in the Varanasi plant, we are taking their data. What's the main process in wastewater treatment is that after the physical filtration, they do oxidation to oxidize the dissolved carbon and nitrogen, which are waste. Now, in order to do the oxidation, they use oxygen, which is costly, and also they liberate carbon dioxide, nitrogen oxide, which is also not good for the environment. Though they come out with a compliance of the water dissolved components of the water to a very low amount, so that they can push it to the river canal. But in the process, they are also using oxygen and generating carbon dioxide, nitrogen oxide, which are harmful for environment. So now, can we generate a sort of machine learning based prediction model or AI based prediction model, which will exactly tell the parameters to control the process parameters, so that the oxygen flow, carbon dioxide generation, nitrogen oxide generation, as well as the compliance of the quality of the dissolved components in the water, all remains within the budget, and we can go ahead. So these complicated things, which have a lot of complex functionalities, cannot be done in a simple way. You need to do AI. In agriculture, we have a project with State DST where we are trying to detect the insect and pests through the vision system. And we are directly making an app which will directly communicate with the farmer and telling what needs to be done. And there also, it should be converted to a normal vernacular language of the farmer. So it means that a lot of AI interventions has been there. Okay, computer vision, okay, classification, and then text analytics. So a lot of applications are there. And actually, if you look into the yesterday's declaration in the cabinet, Government of India has declared around 10,300 crores, okay, to be pushed for the AI development in the country. So this is very enormous, and so in every citizen-centric activities, AI will be coming up. Yes.
Thank you, sir. So one more question, sir, related to intellectual property, which is nowadays very famous non-fungible tokens. So question is, so how we can distinguish between the real videos and AI generated video?
This is a very good question. So you know that recently there is a big news that Narayan Murthy has come up with a proposal where people can just become crororepatis, and the video came, and so it was a video from Narayan Murthy, one of the biggest, biggest successful entrepreneur in the country, having a rich expertise in industry. So he's speaking something. So everybody believed it. Actually, in fact, yesterday in my room, one of the startup heads came and they said, "Have you watched this quantum AI which has been spoken by Narayan Murthy?" I said, "You don't know, it's a fake." So this has happened. So how this can be traced? This can be traced. There are techniques which are called digital forensic. Digital forensic techniques have been come up. So whenever it is generated by an AI, right? You will find that there is some synthesis which has been done on the video. Okay, so you can find the changes which has occurred in the video are changes which are very continuous changes, which can be only done by a machine based rendering, not by a natural. Because in natural process there are a lot of this. The things are a little bit not so well sequenced. It's a little bit random. Okay, so while I'm moving a hand like this, right, in a synthesis video, the hand will move like only this in my video, but when I'm normal, I will just move a hand like this and then I will go here. Okay, so this is what is a natural. Right, but when you generate an AI, it will be just like going like this and this. Only you will see that my hand is only like going like this when I'm talking. But in natural, it will be not like that. I will be doing hand like this, and I will stretching the hand like this, and putting the hand like this. So these are the ways what is the natural. So when you try to look into the particular video, you can see that everything is everything extrapolated. Right from the scene. So those are the clues what you can do, and a digital forensic expert can easily go through that and tell that. They have the tools to do that. Okay, yeah.
Okay, sir, thank you so much. Now we have no question. So thank you, sir. Thank you so much for
Thank you. Thank you for your time, and I was very busy of the day, but still I could able to manage. Okay, thank you.
Thank you so much, sir.